Hello again, fellow foot nerds. Hope everyone out there's doing well. Sitting here on a very cold day in Middle Earth, I guess, and we're going to go through what would typically be a fairly dry subject, but it's actually quite interesting because it's probably one of the most important things we can consider with our patients and customised orthoses and everything that surrounds. Stuart Roseler here. If you don't know who I am, I'm interacting with LBG Medical and the Bio series of prefabricated orthotics. Okay, so let's have a look. We'll get the one coming up. So today's journey, what we're going to have a look at. Really a quick review of the journey so far. We've done a series of 3 or 4 webinars on the different compositions of the orthotic, the customized orthotic. So we'll have a quick review of what we've talked about previously. I'm going to have a look at the top cover, the penultimate thing that goes on the orthotic and can have quite a big effect on all of the different things that go in to make up the customized orthotic therapy, not just the device, the whole therapy that we're trying to do for our patients. Quick review of the manufacture, that always helps. It gets us in our brain of what the materials are trying to do if we know how they've been manufactured and what materials are part of that. A little bit of a touch on classifications. Again, it's a complicated subject. You can classify it in many different ways, but we'll try and classify them into use profiles and then considerations for each of those. So when we're having a look at the typical clinical applications of those, it's sport, essentially, ulceration, so the high-risk foot. We'll have a look at the application into sport. Okay, they're probably the 2 main ones that I get most of the questions on. Comfort is another one, which tends to be a bit less objective to measure. And then another interesting one is energy management, and we'll talk about that later in the webinar. And then finally, we just have a few conclusions about what to go on and back to those considerations for your selection. Okay, enjoy the ride. So where we've come from and where we're going, where boldly no man has gone before, or woman, of course, or creature. We've had webinars in April 2019. We talked about shell materials, and you can find them on the LBG Medical website. Download them at your leisure and have a bit of a chat if you listen to my voice for a good 40-45 minutes. So we had the first one was on the shell materials, otherwise known as the base material, and how that works and interacts with you and your patient. So you in how to manage it, and your patient in the results that you want to see. Next webinar was in July, and it was focused more on the padding and the composite materials in the middle. Okay, so I typically refer to those as the mid layer. And again, quite an interesting topic on providing the solution for what we want to do. And then winding up today, the top covers. Okay, so you can see the evolution of what we've tried to do here in this webinar series. Key concepts from all of those was this concept of ultimate variation. Okay, you've got one problem, but there's always multiple solutions to that problem. And that's the challenge of making anything bespoke. You can do it in so many different ways. There's no right or wrong answer to the one problem, which of course then makes our brains kind of explode a bit when it comes to what am I going to do for this patient. Typically, I'd recommend you go with what suits you and work with a material that you think you can work with and understand. And then if you're looking for problems that aren't getting answered to that, then you can start to have a look at the things that I'm talking about here. Again, another concept and quite heavily in what I talk about is always looking at the underlying construction of the material. All right, it's not just the composites that go into the material. So it's like if we're going to make a cake, you've got flour, eggs, water, some kind of fats, butters, all of those types of things that you need to go. It's the individual components that create the characteristic of the cake, but it's the way that they're put together and processed creates the final solution of the cake. Very much the same in materials and material science. Okay, always look at the construction process and how it's made. Even though it might be the same material, it can have very different properties. And that lights the way for us to then look at what solutions can we get going forwards. And again, boiling it down back to what's our clinical evaluation process, right? The key concept through all of this is up to us as practitioners to kind of capture all relevant data, okay? Consider that data as much as we can and select the appropriate customized solution for that particular case. And it's not always right, it's not always wrong. Okay, it's just a matter of an approach of what are you going to do next and wherever they come from. Okay, we're dealing with a human. Always, always, always consider the biomechanical forces and the anatomy involved that drives the pathology. Okay, you can have a pathology, but each person is very different, and it's the forces and the anatomy of those forces that creates the solution, I guess, and also the problem. So the whole concept of a biomechanical customized device is exactly that. It's customized. It needs to be consideration of the forces and anatomy in regards to a response to a pathology. And hopefully we get there quick. All right. There's my favorite little photo. You know, power of alter variation. It's just a visual thing to remind you of what we've talked about in the previous series, and we'll continue to talk about on this one. There is no one right answer. Good old plastic man. Okay, so in review of all the concepts again, materials plus the shape of the orthoses. Now that comes from a combination of what position you've casted the foot in and your prescription variables, okay, will determine the shape. So we're looking at one small part here, which is the materials of the three groups that we've sectioned them up in, shell, mid layer and top cover. But it's the shape that also can influence those. It's the symptoms that the patient is currently exhibiting or has exhibited or will exhibit, okay? And then of course how you prefer to work with all of those, okay? So it's up to which paradigm you choose to look at and go with that for that particular patient. All right, and if you look at that from external sources, that's a design process, okay? So we're looking particularly at orthoses, but when I refer to the orthoses design process, that's what we're talking about, putting all these things together. And the lovely thing nowadays is there's a big old digital component to that. Okay, we can do and look at all of these, and that's an area that I'm particularly passionate about, in getting this to come into a more computer generated or computer friendly way. And that's with all the reductive and additive manufacture that's coming on. So that's an area that I'm looking at quite closely. Okay, well done. You've got this far. We've got through the quick review. Now let's have a look at the top covers. Okay, so and this is a bit of an idea of where we're going to go for the day. So back through, and we'll keep referring back to this so you know where you are in the quite complicated pathway that we can take with these things. So, like me, if anyone out there who's considered what is a top cover. I mean, I ask my patients, what is the foot? What does it do? Okay, and a lot of them say hurt, but a lot of them can't answer what the foot does. And then if I can answer in a way that it's shaped in the way that indicates its function, so what it's designed to do, that then leads them to start to have a deeper understanding of the complexities involved. And I try and do it in a very simple way, but it's a very powerful tool to make them think about why things are shaped the way they are. If we do that same thing with a top cover, what is a top cover? I mean, it's the last thing you think about. It's not really that important. But if we consider that in the context of where we are, it's the primary interface between the human and the skin. Okay, so sorry, between the human and the device. Right? So a top cover is really the front end of what we do, outside of pushing someone in a certain way according to ground reaction forces and what we want there. But this is the thing that the people feel, okay? It's the thing that the people will want to respond to. It makes it comfortable. It's kind of the nicey feelies, but it also can have a very technical, functional purpose. And all too often we think of it as an afterthought. But if you kind of flip that and think of it, well, this is actually the primary interface going on between what we're trying to do and the person that we're helping, okay, the human. So sometimes you could think, isn't this the most important thing? If we're trying to do something, we need to interact with the patients in that way. All right, so skin to top cover. Again, it's the interface between the skin and the material. When we're looking at a top cover, the things to think about are the types of forces involved. It's easy to just say a force, but think about the types of forces. We've talked about them a lot in the first webinar series: shear, torsional, friction, and pressure. Okay, what's available, what's there at a certain point in time, and what results do we want to see? Okay, how these forces behave. You know, you can have a shear force, but is it behaving rapidly, slowly, chronically, acutely? Okay, all of these different things are coming in, and a top cover can help us manage those. All right. They also consider the shear force may be an internal shear force, so that soft tissue in between the skin and the bone. All right, any of the tendons or ligaments or processes, essentially the goo, that can be influenced by shear forces. A lot of what the guys in the tissue stress theory talk about. Is it an external shear force? Okay, something it's actually on the surface of the skin, typically called friction. Okay, so back and forth. What size is it? How big is it? What direction? How long? Particularly these types of things start to then again drive our thought process into what questions do I need to ask to help me answer the questions that I need to answer according to the pathology that I'm trying to treat. Okay, again, skin characteristics. So this is all related back to top covers. Is it what's happening in the local area? Is the circulation being influenced by a process? Is it a sporting condition? Is it a naturally hybrid, a very sweaty person? What's the purpose of that skin in that area? Does it need to be thick and bulky, or is it thin and fine? Generally in the plantar surface of the foot, it has different characteristics depending on where you are in the location of the foot and the way that person moves. Hair, okay, what's its elastic properties in that area? Is there a lot of sweat? Like I said, all of these things can have a big effect on what top of cover you may consider. And again, anatomy, so local purpose, the bony prominences, the cellular functions, and the neuroanatomy, okay? Again, hair. So a lot of these will repeat themselves because they're slightly different but the same. So skin characteristics points more to what is it in isolation today, and then the skin anatomy is really what does it function to do in an ideal sense. All right. Again, is it in a problem state or is it in a happy state? All of these things you may drive what you see in front of you today. You may end up with a different top cover tomorrow when you've got the condition under control. All right. Is there any objects that are you need to consider? All right, particularly in a working situation. Some people have a high content of water, dust. Okay, they need to put creams on, whatever it is for dermatitis. This can all affect the forces and everything that goes around. And of course, the interface for that and the primary intent of that is the top cover. Okay, so all of these types of things are again really quite complicated when you start to think about it, but very worth thinking about for that tricky patient. Again, the aesthetics of the top cover. Okay, it's something that I typically put black on black and put it in a shoe and it's black, and there we go, it's black. All right, but I'm very familiar with a customized device, and I've seen a million of them. But typically, people want to feel good. They want to, how will I put it in my shoe? If it's a lovely kind of leopard print, and I love leopard print, go for it. Okay, it doesn't hurt at all because it's all to do with that patient engagement, and we're really trying to get people to do what we want them to do. Again, comfort. Why do people come to us? Here's a tricky concept. If you've ever had braces on your teeth, you don't go to the dentist and get your braces so they're comfortable. you get them for some portion of correction, but there is a comfort state in there. Okay, comfortable enough. All right, the same kind of thought can be, thought about an orthoses. Do we get that in, accommodate to what it is, make them comfortable initially, and then gradually progress them to the position that we want, or do we have enough play in the system to do it straight away? All right, but again, the top cover can have a big influence on that direct interface and comfort of the patient. And that's what we talked about there. What do we sacrifice for comfort? So all too often we may see that we're not getting the clinical results we want because the orthotics are not comfortable enough so the patient won't wear them, or too comfortable that they're not creating a functional change. And that's the challenge of dealing with a human. Okay, what are we going to use them in? How are we going to use these devices and ergo the top cover? If we're going to go into a small shoe, we haven't got enough room for the foot, the shoe, and the device to fit in, and there's the considerations and the challenges of what material will I best go with for this situation. And again, maintenance is another big one. Okay, can they be managed, clean, replaced, all of that type of stuff? And if you think of a top cover, it is really the interaction of the human to the device, so it should be some kind of design process factored in that it needs to be replaced on a semi-regular basis. All right, and acknowledge with the patient these are a usable working tool. All right, all of these stuff, again, to make it super complicated, why we get paid the big bucks as practitioners, all of these factors correlate to each other in some way, okay? And it's what we do that helps the patient get better, but it's what the patient does that has the biggest effect, and all of these can have a different effect on each other. So not to overrule it, go simple, go with something, test it, and then get your results as you see. But a part of that is factoring into your clinical practice objective outcomes and objective measures as much as we can. If we can get an objective outcome each time we record what's going on, whether it be a position, an angle, a space, a feel. If it's a feel, we do it on a sliding scale and we record it. Okay, if we can record it in a ones and zero, we can prove that it worked or didn't work. That's the beauty of those types of things. But as I said, all of these types of factors could be very easily put into a review form. Right? What types of things are we looking at there? And it's telling us whether this top cover and or orthotic device is working and push us in the right direction for that patient. Well done. Okay, now we get into the manufacturer. Sometimes this can be a bit fun. Depends if you've got an engineering brain or not. So foams, essentially, most top covers are a foam or a foam and a substrate laid up. Some are kind of woven materials, but by weight of average, it's mostly foams, and that's done with a foaming process, which is quite common to a lot of the foams that we see. I'm going to pick on EVA just because there's a bit of information on it, but EVA, which is essentially the similar processing to Poron, to a lot of the ones that we see, it's done in two ways, or essentially the base, we'll call it EVA, is foamed in two ways. Injection molding and compression molding, right? So injection, where they inject the substrate material, so the base material, into something and pump it out, and then compression, they compress the stuff and heat it and do that. In both, air bubbles, okay, are created or included or added. Air bubbles are added and high heat are applied, okay, and this creates an open or a closed cell structure, similar to that of a sponge. And it's what makes the EVA foam so very usable. And of course, it's a process. You can apply that to the different polys out there. Here's a microscopic look at open cell and closed cell. Okay, so the one on the left, closed cell insulation, creates that air pocket, which in turn creates a recoil or a bounce in the material. A more open cell construction will be energy absorption type material. Okay, it will kind of squeeze through and punch out, but in time, and that both, as you can see, will affect the durability of that. So when we talk about open cell or closed cell construction, most foams and top covers are closed cell in orthotic manufacture, just because of the ground reaction forces that we're talking about. But some mix the underlying material with different characteristics, so your slow release and slow return will still be a closed cell material, but it's based on a different polypropylene or a polyethylene or acetate combination that will respond and return gradually. Okay, but this is basically the construction process that most foams go through. Okay, like I said, the one on the left is the one that we primarily see. Let's see if this little video will work on the, okay, maybe it will. Nope. Okay, that was a little example of a compression foaming. Essentially, they put the molten or the unfoamed material in between all these press, squeeze it together, and inject air into it under heat, and then let it expand out on a fairly rapid process. But it's all very controlled. Go and have a look at it on YouTube. Okay, now we're into the classifications. This can be quite tricky to do, but do we classify it on material? Is it what material, the base material that we use it for? So in the plastic ranges, we've got your polyethylene foams, your polyurethane foams, your ethyl vinyl acetate foams, and your synthetic rubbers. All right, so all essentially a foam, but just different base materials, and they can be classed as such. You've got your natural products, okay, your leathers and your corks, and again, this all relates to top covers. All right, we're focusing on top covers here, but you can definitely apply it to the base shell material and the mid layer. And then of course your carbons. Not so common that you see it on a top cover. Pure carbon it tends to be vinyl in a carbon-like weave. But again, there is kind of the classifications of the different ones out there. Okay, we can go a step away from the material, the base material. What process has it been put under? Okay, has it been woven? Has it been blown, or has it been layered up? Okay, so carbon traditionally is a layered up process. Some of the materials, as you would know, are woven together, and some again are blown, as we've discussed, or foamed, like we talked about before. Okay. Interestingly enough, the classification can come from supplier. Okay, we talk about Nora or we talk about Poron. They're essentially, or even neoprene and Spenco. They're all from different suppliers, but it's academic on the slight differences between both. For us, in what we're trying to do, I would suggest it's fairly negligible. Okay, but again, there's some suppliers out there that have the rights to certain things. And they're available. You can definitely get the same characteristics in a different way, but it all comes down to the proprietary rights of that recipe, I guess. And of course the process of doing it. A lot of the carbons have the same base material, but the ultimate variation on the process that it is to make the carbon strands to weave it together. Yeah, and which brings different ones. I guess the main one that we want to, well, I would say to look at is how we're going to use it. All right, so we've got 3 options on how to classify it. Let's look at how it's used. Okay, and that's what we'll do here today. Again, ultimate variation, always relate it to the condition you're treating. All right, so that's the use. Okay. And again, we touch base back on what is the best top cover for. So I get on the phone or in clinics, so I go and talk at conferences, and everyone's saying, well, what's the best top cover for this? I've got a patient that does this, this, and this. Help me analyze why they're doing it, and then what's the best top cover for it. It's essentially what we do all day, every day. Okay. There is no straight answer, unfortunately. What I would say is let's have a look at 3 or 4 of them to say what is the one that is most often used and typical for everyone out there. All right. So high risk, and that's for those that have a risk of some kind of ulceration or response to pressure that you don't want. All right. That's probably the most common one that I get for what top cover to use. Of course, sports, we all tend to go to the traditionals. We'll have a look at those. Comfort, which is a bit less objective. We kind of need to use a bit of creativity in our brains to think about comfort, because it's a discussion with the patient more than anything else. And then I've termed this energy management, but it's really the distinction between, are we trying to absorb or return energy at a certain point in the foot or the process that the foot is going through gait. Okay. Again, back to the fundamentals. Consider the forces and the anatomy. Multiple options for the same thing. No best answer. Okay, ulcerated foot. I love to put kind of horrible photos of ulcered feet on there, but when I think about the ulcerated foot or the high risk foot, it's actually quite a tricky decision process to do because you can't get it wrong. So this image just really displays a concept of it's more about our thinking than what is right or wrong. What are we thinking and what, because we need to manage this patient in the way that they've got to where they are. Okay. From my background, I'm not an expert in this field. There's many people out there that are far more akin to what the ulcerative foot needs. I'm looking at a pure materials and design process concept. Okay. And the way I've approached it is the consideration is the ulcer has come from somewhere, or the problem of that we're seeing has come from somewhere, and I'm focusing on what movement and musculoskeletal anatomy is involved and try and manage that load, and again not looked at the underlying disease process or something that's going on behind it. Okay, in that world, we've got to consider the peripheral neuropathy. Okay, so essentially the problem with anyone that's a high risk from a disease process that's come along, they've lost that protective sensation. Okay, and this in turn allows for abnormal zones of force or pressure to occur. Okay, so they don't know to move their foot. They keep moving it in that way, and then of course it breaks down, or there's other things that are going on that cause them to have the problem that's presenting with us. Okay, so very tricky to manage. And again, going back to now that, well, the next step is, they've got the neuropathy, but is that what disease state? Is there a lack of blood flow in the area? Okay, that's allow the tissue in all intents and purposes happily live with the forces that we're putting on it, but it's in a diseased or a problematic pathological state, and the skin tissue or the soft tissue isn't able to repair as well as it otherwise would. Okay, so we may have to put them into a foam walker or a crow boot or something like that, really, because the disease state is dictating it to us, right? So top covers there can have an effect, but they're not the only answer. Okay, and again, dry states of dry skin. It can be an autonomic type stuff. Fluid, the typical ulcer that occurs, there's the fluid in there, and that's generally, if you look at the inflammation process that goes on in all over the body, that's what's happening there. So the body's trying to kind of do something about it, and it can't do it. So the fluid goes, well, north instead of south. And again, from those states, is there any physical deformity that's occurred in the foot that otherwise wouldn't be there and we need to manage? All right. So again, the chronic nature of the movement can affect the bony anatomy, which will then, affect the alterations that we get. So back to the point in case, traditional top cover combinations that we tend to find for these types of feet. You've got your polyethylene, polyurethane, EVA foams, and your rubbers and your natural composites tend to be the ones that are used predominantly that we see. Outside of these are all outside of your base and mid layer considerations. You may get one characteristic from a mid layer, and you kind of combine that with a certain top cover that will give you the solution that you're looking for. Yeah, so again, it's not a clear picture, but traditionally we see it's a lot of the PU and PE foams. So traditional characteristics of a top cover that comes into this, high risk foot, it's inert in nature. Okay, so it's very low reactive, doesn't interact with much anything at all. UV states, it depends on the range. Antibacterial properties, and they're playing around a lot with additives within the foams and top covers that you can get. Of course, it comes at a price point, but typical ones are, silver, honey, and there's PHMB, which is essentially a new one they're playing around with. Have a look, Google that one, and have a look at what they're doing, different types of things to help reduce the bacterial load, essentially. But of course, it all is in conjunction with your good process of clinical checking and getting the patient to engage on how to care for themselves. Whether it wicks water or repels water or moisture. Okay, that's also quite an important one for the particularly the woundy foot, the one that's producing exodus coming out. You need some type of top cover that will allow to do that, and low microbial nature. And of course, then all of these, it's good to wick and it's good to kind of be antibacterial, but in the context that I'm coming from, you want to manage the force that's causing it in the first place. All right. So, and again, where are they? Shear force, peak pressure, how long it's been, the force is being applied for. Okay. So typically we'll see plastozote, okay, and this is a closed cell again. There's that term, closed cell cross-linked polyethylene foam. So essentially it's been blown, the air bubbles are closed cells, so it provides a bit of a bounce. It typically doesn't have too much lifespan. It's kind of compresses, but in that it molds to the shape of the foot quite well. So I'd say this one needs to be made in conjunction with the mid layer and base layer considerations as well. But again, it's quite easy to replace. It's quite low allergen, and it does everything that we need it to do. It doesn't have a good elastic memory, which is the inverse of it molds to the foot quite well. It won't recoil, it'll kind of absorb. So you can get that really close fitting fit to the orthotic with this as a top cover. But it does bottom out, so it's not designed as a supportive structure. Okay, again, redistributing of the plantar force over a wider area has been recognised as one of the things that we're trying to do with that. So we're trying to spread the load. And I would say it's a good multi-purpose direct intent top cover, and it's probably the leading one that we use for the diabetic or high risk foot. Okay, porons as well. Okay, that tends to be next on the list. Open cell, low compression jet urethane foam. So again, if we go back to we've got a plastozote, it's a closed cell polyethylene, open cell urethane. All right. This one can produce shock absorption. So if you've got that really rigid foot and you see the vibrations going up, the leg from when they walk, you can get this. But again, the mix of that and a poron and a plastozote can provide the thing that you're looking for. Again, it wears well, so it will recall. It's easy to fabricate. It's resistant. And again, it resists bottoming out. So plastozote will bottom out, but poron won't. But generally, it's got less shear resistance to it. So the combinations of plastozote and poron come in quite well, all right? And so that's when we start to look at the two there. And you can see what we've done here, all right? So base layer looks to be a medium density EVA. You've got a poron mid layer and then a plastozote top cover. Okay, and the whole idea is to reduce the amount of peak pressure on the foot, and the way that we do that is contour to the foot. All right, the importance of a customized process or tailoring it to the patient. What we do. One of the things that I like to consider in all skin tissue is the subdermal and peridermal, I guess, the top of the foot. Is the shear force. Okay, so one of them to consider in that ulcerating foot is what twist is occurring to cause the twist in the skin that's causing the ulcer in the first place. Okay, this version is a product made by Orthotic. Again, it's a closed cell cross-linked EVA foam. So it's an EVA closed cell, and they're all linked in together. And again, so it's a resistive to ground reaction forces, and it'll push up back well. But this one particularly, with the combinations of the recipe, the eggs and butter and milk and flour that's gone into it, has very good shear properties. All right, and shear properties is it'll kind of tend to deviate and then come back. It won't tend to tear as well. All right, and that can have a good effect. Again, this one's designed to be a direct intent top cover, so you can put it on directly onto the base layer, and it's got low microbial properties. Lunatic motion, and I'm fairly sure the poron vibe is the same one there. All right. Yes. talked about all those. So considerations for the high risk foot, or the foot that's at risk of ulcerations, or any other high risk pathology, I guess. Just looking at the research, about 50% of all the ulcers that have been recorded in this study occur on the plantar surface of the foot. Interestingly enough, 50% don't. So let's say, more often than not, it's going to happen on the plantar surface of the foot. But, I'd be interested to see where else it occurs, probably digits, I would think. But from there, it's just to point us in the direction of consider the base and the ground reaction forces. And then consider that in the quite well recognized concept that contouring to the base material, okay, the shell, so how it fits to the foot seems to be the biggest influence in offloading that foot. All right, and there's a lot of studies, and Yick has just done a more recent one. They're getting better at recording it. But again, it comes into, we still haven't got a certified way of how do we measure this offloading. Direct pressure that you see in the sports stores is one way, but it can be a matter of function and interaction of joints that cause the loading, and patterns of muscular tension or tightness and weakness. All right, how do we measure it? And the insole stuff that's going on is quite good and quite groundbreaking. We're just really waiting for the data sets to come out. So the question is, how do we measure it? What positions do we as clinicians capture? So this is a huge bugbear of mine, I would say. If you're going to try and make a customized device, you need to know your reference point of what have you captured in space or on the ground, okay? If I've captured a foot that's plantar grade accidentally or on purpose, I need to acknowledge that in my prescription and my design process, all right? But more often than not, we'll find that there's been a plantar flex first ray on one, a dorsiflex first ray on another, and unfortunately, what is required is neither. Both need to be neutral kind of plantar flex, but again, if we've captured it, we've got to use that as a reference point and adapt for it, as opposed to capturing what it is we truly want to work towards. So again, flags out there for all of us to be really good at our casting, and again, it's what we get paid for. So casting includes scanning, all right? The same process, we have to follow the same processes that we always do. And another big one I'm looking at quite closely across all manufacturing softwares is what does the software capture? Okay, we can capture 1 million points, but what does it then use its computer brain then to calculate? All right, and the word smoothing comes into my brain. Okay, so we've got to make sure that we know as clinicians what kind of smoothing is occurring in the shape that we're capturing, all right, within reason. But again, if we leave it up to a computer, no one knows what they're doing. So we've got to make sure that we own the process. And of course, that's in the software side. But then, okay, what do we do when we get that good shape? How do we manufacture it? How do we treat it? Do we reduce it, increase it? Do we take a bit more of the thickness out? That'll change all of the properties that we're trying to do. All right. And then, of course, what combinations of all of these different things works best? So to contour to the foot is one thing, but what combinations of all of the base, midline, and top cover work best? And again, there is none that they point towards. So in summary, for the high-risk foot, you've probably got your plastozotes, your porons, and your lunatecs that tend to be the ones that tend to be combined together for those. Okay, the sporting foot, welcome to rugby. Here we go. Again, going through your biomechanical assessment and clinical thinking process, you're dealing with a sporting patient. Again, basics of what type of sport are they playing? And of that sport, do you know enough about it to understand what it is that they're doing? A golf person, playing professional golf, may not do a lot of endurance or explosive power, but they may do in their training. Okay, so you've got to have a pretty good idea of not just the activity that they're doing when they mention a sport, what goes around that. Typical there is I've spent a lot of time with shooters, okay, and their heart rate needs to be low, so they spend a lot of time on endurance sports to try and reduce their heart rate and extend the period between beats, okay, so they can have more time to line up and shoot the target. Okay, very interesting, because you wouldn't think that a shooter needs to be very aerobically or heart fit sense. But again, it's a competitive advantage out there. So anyway, I digress. So sport type, look at it, the different types of sport and what's entailed in each of them. Static strength, dynamic strength, athletic kind of prowess or positioning type stuff. What's the athlete profile? Age, gender, composition of that athlete. Are they a mesomorphic or ectomorphic type? Is that applied to their sport? All of these things can come in. Big one for athletes, huge one for athletes, is their expectations. Sometimes they'll come to us as practitioners and say, I want you to help me win the next, and if you don't, that's your problem, not mine. All right. So it's managing the expectations of what we're trying to do in a nice way, but in a realistic way. What is it they're presenting for? Okay. Is it something that we can do? Is it something that we can add to, or is it something that we can, reduce or even aggravate? So again, knowing the mechanics of the sports, the mechanics of the injury. Okay? Again, if they're coming with some kind of thing, we've got to truly, honestly understand the mechanics of the injury. And if we don't, go to our fellow practitioners, have a chat, talk, discuss. You're only going to win by doing that. Okay. What nature of it, of the presenting condition? Is it acute, chronic? All of these types of things can have a big influence on the top cover, on what you're going to choose. And again, stage of training, they might be, in a low zone, so they're not going to use the device. They might be in a high zone. They're not going to accommodate to it. Shoes, we all know this. As I said, it's kind of coming back into, essentially a sporting foot is a typical foot, but the use is not just what they do in the dailies, what they kind of aspire to do and concentrate on. And again, it all comes back to your treatment paradigm. What is it that you prefer to do? Practicalities for the sport, okay, when we're considering it, it's sweat, space available, and feel. Okay, they're probably the three main ones that I can think. Sweat, obviously, lots of activity, lots of sweat coming through the feet. What space have we got available? Football boots are terrible for trying to fit anything in, but again, they might be used for an hour or two a week. All right, so what are we trying to do as a process to change this pattern? And of course, the touchy-feely, if an athlete gets in there and they feel something just slightly different and they're a bit off, they'll point to everything and anything other than an internal process to get on with it. Okay, so feel is a big thing. Again, forces, always back to forces, all of these things that occur in the sport. Again, expectations, lifespan, wear patterns, replacement cycles. If we can manage this from the word go and get them to understand that, these are the things that we can do. And in my area, it's manufacturing considerations for all of these others. Okay, what material bonding is there? What rotative forces, placement of pads, all of that type of stuff. How do we measure it? Comes back into what top covers we select. Traditionally, neoprene is the kind of winner. Okay, neoprene is designed by DuPont, and Spenco is by Impulse. Okay, I would say very similar for what we're looking at. The recipe is slightly different, but both are typically similar properties. Neoprene is a polychlorine. Okay, and again, by it being a poly, it's polymerization of chloroprene. If you have a look at the composition of how that's made, you'll see the rubber material and how it comes together. Essentially, it's a synthetic rubber that's good UV stability. Good chemically, it maintains its flexibility over a wide temperature range. Very good at insulating, but can tend to be hot because they feel it on the surface. Okay, and it repels water, right, like the wetsuits. I will say that it's difficult to manufacture, so the finish of it is always a bit kind of rough. And there is, some people are allergic to the neoprene or, interestingly enough, the manufacture residues that go into the neoprene manufacture. All right, again, if we go out of that, it tends to be a really tricky thing to get something that's a neoprene that's a low allergen because of the processes that they follow. Another one on the market is the bamboo or bambalon. Okay, so it's essentially a neoprene with a bamboo fabric cover. Right, again, good for the sporting foot. Tends to be quite a better profile at wicking. Okay, so it can take the sport away, but it does wear quite a lot quicker. Not a lot quicker, but it wears quicker than say the neoprene. So if you engage with your patient, say, look, you've got a sweaty foot, we need to replace this top covering in a certain period of time regularly, they'll be fully aware of that. Okay. And again, it can be the low bacterial loads, the fungal loads, deodorizing, essentially bamboo. And again, it can look quite rough on a finished product. For that. So some of the little lab tips that we could put together, if you're going to combine anything and put it together outside of the neoprenes or the spencos, one of the tricks I've used in a clinic often is to get a base top cover, rough it up, and then stick some neoprene on it. Okay, what that does is the neoprene will come off. Great, replace it. Come off again. Great, replace it. Okay, so it's really one of these usable type things that the sports person can keep the device going and being used, and you're constantly getting them come back to visit and replace the top cover. All right, so abraded vinyl, typically you can abrade suede or anything like that and put the neoprene on top of it. I've used XRD, which is your slow release porons, and suede on top. Okay, good for frictional properties, all of that type of stuff. Same again, porons, Lunatex. Again, play around with it. You can see what I'm doing here. You can pull all the above 94s, XRDs, all of that with EVA, vinyl, depends what characteristics you want. All right. The foot requiring comfort is a very difficult one. As I said, as I talked of before, comfort versus clinical effect is one of those things that's, you've got to weigh up. Is this going to be an engagement process, or do I need to push them in a certain way and they need to essentially take it? Consider all your externals to that. What stage of therapy you're in? Is it long term? What type of base material? And again, contouring of the foot. Benno Nig talks about neuromuscular feedback here. So comfort can be quite an important thing, and do orthoses work? It's more about the muscular feedback that the lower limb muscles will fire in a certain way depending on what they feel. Very interesting stuff, worth a look. Energy management. Okay, so what is energy management? Essentially, a force is a form of energy. All right, forces in the world can be neither created or destroyed. They're there. They're just moved from one to another. We as practitioners can only redirect this energy to another state. All right, so looking at force, we're looking at where do we redirect it. So when I talk about energy management, it's us as clinicians planning how to manage this redirection of energy and where to put the forces in a certain way. So as a simple sense, we want to consider the redirection. Do we want to dissipate it, or do we want to manage both in a certain way? Okay, and that's what we're doing with the top cover. So the role of top cover in this energy management, it's primarily shear force. All right, how do we get this kind of shear force under control? Again, a frictional force is more a superficial thing. So it's to do with the resistance to movement, and that's the friction as a measure, whereas shear tends to be intrinsic to the muscle, the tissue, and or the mid layer and the top cover. So shear forces can be managed by the amount and different types of top covers that come on. Again, if you've got a vinyl top cover, shear forces aren't really taken into consideration because everything will slip. You may want that. Okay, and of course the third one in energy management is your ground reaction forces, but that comes back into your shell and your mid layers. All right, again, we talk about pressure a lot, but just of interest, pressure is not a force. It's a measure of force per area squared. All right, so when we talk of pressure, what type of force is it that we're talking about? Generally, it's ground reaction forces, but the different forces that go in can mean the same pressure. It's just a different type of force. All right, so that's just one for the academics out there. Top covers that are designed to deal with these different types of forces. Okay, so you've got your shear forces, you've got your abraded poron vives and your Lunatex, as I talked to Lunatex, as I talked before, and then you've got your neoprene and spencos, which tend to absorb some of it and repel well. You've got your frictional forces, okay, the ones that will resist the slip. Okay, suede, there's one out there called cambril piqué. Okay, and again, it's also interacts a bit with the bonding material, what we bond the different layers together. So just be careful of that. Not that it's a big problem, and most labs know what to do with them, but you may lose some of the effect of what you think that the thing is doing. And then we put a bonding glue on it, and it changes the properties. Braided leather or EVA, tend to find these shine over time. So yep, good initially, but they'll smoothen off. That also can tell you a bit of a story on what's going on in the patient's shoe over time. And then another popular one is for friction is pour on with a substrate. So it's your typical pour on with a woven base. And of course your shock absorption stuff, but again in a top cover, it's generally the mid layer that deals mostly with your ground reaction forces and or the shape of the device. All right, so almost there. Selection considerations. Materials research, as we've discussed many times before, it's a wide range. There's lots out there, wide range of materials. It changes a lot, and sometimes even manufacturers don't know that the changes have occurred. It's the suppliers that will tweak it, and they can charge more because it's a new thing. Go with what you know and go with the principles of what you're trying to deal with. And if a new product comes on the market, have a look at how it deals with those principles for your patients and the way you use it. You're going to win some and lose some. Okay. They're all very difficult to compare because the basis of comparing different materials is done with different rules, different measuring sticks, and what is best for those properties that go on there. There's a lot of confusions over trade names and labeling and characteristics, and it's really, that's why I think most people get a bit flustered by it. If you go back to the the chemical names, you can work out what's in them and go from there. Always interested to have a chat about the new properties out there and what they mean and what they're composed of, if we can find them. Again, reviewing back the design process, materials is one small part of the big thing. Orthoses shape, what we prescribe and what we capture in our casting and scanning, the symptoms that you're trying to deal with, and your preferred paradigm that you want to work with. Okay, and consider that all in a design process in the digital area. Okay, and that, again, that's what I'm really quite interested in going forwards. All right. A bit of inwards looking. Why do you choose the material that you choose? Because you heard someone said, some Aussie bloke on a webinar said it was good. Test it out for yourself. It's up to you on what you want to do. Okay, the clinical reasoning behind it is yours. All right. So, and we've got to record that and objectively measure it backwards. All right, in going forwards. How much attention do you pay to the research? Again, it's very complicated. I'd say it's a level 5, quite low on what's out there. But the temptation is that it can be quite a high level of testing, because you can do a blinded trial for all the materials. But again, it's what kind of composition have they put them through? And again, back to the methodologies, methodologies that you prefer. Endless possibilities. Always relate it back to the patient. And just advice for the new practitioners out there, just make it clear. Okay, short, simple sentences. Make sure you document what you're thinking, and then review. All right. Simple as that. There's the diamond. There's that good-looking rooster there on the right. He's got a good shirt as well. God, yeah. Not getting any younger people. So in this process here, you want to think of a diamond. You want to collect and evaluate. Give yourself enough time and space to do that. Let the patient talk. Direct the questions to what you think's going on and what they've come in by. Give yourself time to consider, okay, and then apply and review. So focus it down to the thought process. And if it's not working, go back up to the consider. You may not have collected all the information. So this is a triangle upside down, or diamond, that we're looking at. And that's how I think in my clinical process. Again, thank you all for your time. Enjoy the challenges of putting a top cover in combination with a mid layer and base layer, a shell, together. There's no one right answer. It's always fun to try and get challenges and say, well, that didn't work. Why do we go forwards? But also enjoy the ones where, yep, that worked, and they refer their friends and family to you because they think you're the best thing since sliced bread. I'll see you all soon on these formats. They're quite fun. A bit hard to interact with just speaking to myself, but there's lots of different formats I'll interact with you coming soon. So been a pleasure. I'll see you all out there in the sporting world, well, sporting, manufacturing, digital world, all very soon. Cheers.